Hello and welcome. Um, we One of our lunchtime seminar series. I hope you're all well. Today we're going to be talking about how we could be creating a web crawler. So I'll be walking you through some of the interesting aspects of why we need a web crawler and what the part it plays in the data collection process and why we might be using it for various reasons. And also showing you a very simple example of building one using Python and Beautiful Soup. Without further ado, let's have a look at what we've got in store for today. So web crawlers, so I'll be going through some of the basics of how they work, some of their practical applications, as well as ways that we could be essentially thinking about their ethical considerations and best practices around that. Let's have a look then at how a typical data analysis pipeline might work. We have got here an example of a diagram that showcases the typical steps when we do sentiment analysis and when we produce stuff around data that we might need for that. So we could be doing loads of different things. We could be, for example, using data that we already have recorded around, for example, documents or tweets that we might be wanting to use. We would have that data that we would want then uploaded someplace and then data being cleaned. We could be using directly social media data that we feed into API pipelines and essentially retrieving that data as it gets created and feed that into some sort of data cleaning or some sort of database. But it could be that we decide we want to essentially use data or information or text in this case that has been already published or has been be made available on a website, and to extract that using certain tools. Now, a very typical way sometimes that has been done in the old days is by simply copying and pasting or storing and saving the whole web page. However, with the emergence of these little tools called web crawlers, we are able to essentially go inside a website and look inside the structure of that page and being able to extract information before we, of course, progress into the next steps of transforming that data, storing it, and doing more of these machine learning and data analysis processing. So today I'm going to cover this bit here. I'm going to tell you ways that you could be essentially, and some tools, introducing you to some tools that you might be have heard of before, that you could be essentially taking some elements of websites and storing them into a database or a data frame in Python in some respects. So, what is a web crawler? It's got this little connotation of a little spider that walks around. I mean, the reason behind it is because they have been around for as long as web has been around. And because, of course, your web is like your spider's web, you then call these little scripts or little software that goes around and collects data, a web crawler. So it's also known as a spider or a bot. It is an automated program that systematically browses the web to index these web pages. What that means is that it takes a copy or it takes element from a specific page, and what it does, it systematically stores it into a space, and only that it knows where stuff is, so that next time it can go and retrieve that information much quicker. How are they used? I mean, this isn't something new. This is something that most search engines have been using, and actually more recently, some of the data models that you've been working with that are being used by generative AI have been based on collecting data using that method. But it's the usual way that these tools would be updating, retrieving initially, but also updating their web content, and also where they know where to go and look for information. How does it work? We normally have the first time that a web crawler might be interacting with a set of web pages is they will probably go through a set of URLs that you have defined. They can't just go around and search everything. They will need some sort of starting point, and we call these the seed URLs. The seed URLs will then be essentially used as a list of starting points for that web crawler to work through. And what they will do is they will go parse that HTML and then download whatever content you have indicated you want downloaded into a database or a CSV or some sort of temporary database in the memory. Then they will do further crawling to identify hyperlinks within these HTML pages that they have downloaded and found, and we'll add them further to that list of seed URLs. So what we sometimes call the crawl frontier, which essentially are the boundaries of what can be searched and what can be indexed. And as soon as this is stored and retrieved, then these will be indexed for further work. So essentially, it's showing this as a linear thing right now, but it's essentially kind of a loop kind of thing. So it's an iterative process. So what I'm summarizing these steps here for your reference, so so that you essentially have got the written elements of that as well as part of the slides. The lovely thing about indexing in the last step is that essentially not only will they know where it is that they can go and get more of these elements from, but also they can make the content searchable, which means that then it will be visible and discoverable by the next steps in the process. So you don't really have to the kind of asking and querying of that system will be really, really quick. Typical application areas of the crawlers. I mentioned search engines before. It's being widely used for market research as well. So this is one very useful way that data can be gathered on various things, competitors, prices, trends, where that data isn't stored in a database and is not made available as a data set. And then eventually for content aggregation as well. So the data that's crawled, the data that's collected in that way can be organized from various sources for news, for blogs, for social media platforms, and essentially becomes a data set that can then be worked upon further. So when it comes then to use cases, how and what are the more specific areas of where we could be using crawling? They are a very useful data collection tool for when it comes to machine learning and data science. I'm listing here some examples, but this is not an exhaustive list. For natural language processing, for example, we have been using it quite extensively for collecting primary data around websites, tweets, social media posts, where this is allowed. But also chatbot development and a diverse application area where we need text, such as applications around collecting opinions and essentially analyzing these further, either qualitatively or by means of machine learning algorithms. For market research and competitive analysis, for example, you have reputation management tools which essentially manage what's written about you throughout the web. The way they do that is by searching for information about a specific keyword around the internet, monitoring pricing changes, gathering customer reviews, helping understand the trends in the market, as well as the preferences of the customers by means of what they post and what they publish and what they talk about. And of course, very interesting, more recently, real-time data analytics. So it's essentially where you do quite a lot of this analysis on the fly. So as it happens, you formulate that trend, you formulate that opinion, and in a dynamic way. So that is really interesting because it provides some real-time insights for monitoring. So breaking news, it's been used quite extensively around predicting prices or predicting trends around the economies and how people feel about certain elements. So interesting application areas and where data can be collected in that way there. So what are some of these tools and technologies that you could be using straight away that aren't really kind of complex at all, especially if you're using Python, but even if you don't? The one that I have been using quite extensively in my work is something called Beautiful Soup. Quite a lot of our students are at the University of South Africa using these as well for NLP related activities. So this is a Python library that allows you to parse XML and HTML documents. It is fairly intuitive. I'll show you an example. It creates what we call as parse trees. So essentially, it's like iterations of parsing that HTML and extracting the information from it as relevant. So I've included a link to the documentation, but definitely loads of tutorials available online for you to explore and see in that space if you wanted to. Second one I would highly recommend is one called Scrapy. That's an open source web crawling framework for Python again. It is very robust, is really approachable to people who've not used that, not worked in that space before. It lets you extract data. So very, very popular, actually sometimes more popular than Beautiful Soup. And the final one I would highly recommend is Selenium. That one is an interesting one because it doesn't really necessarily involve you. It has an alternative way of you extracting information that isn't about writing it in Python. So it's like a browser extension, or it can have a browser extension as well. It's more of a tool for automating web browser and web crawling, and it lets you interact with specific pages and specifying in a low code way how you could be extracting data, especially for dynamic content and content that changes quite a lot. Again, I've provided the link there, so if you later on go and have a look at the slides, you should be able to go directly. Of course, if you search for the package, you should be able to find that. So here's a quick demo then of what that looks like in reality. So I'll switch to my other tab to show you an example of what we've been doing with one of our community of my students. So they have had the task of working with customer reviews. So they do sentiment analysis and other kinds of information extraction tasks when it comes to these data. And the first thing that they have to do, of course, because there is no data set per se, including all these reviews, is to go in and find a way of extracting some of these reviews. So what do these reviews look like? If you go, for example, at the homepage of the Healthwatch Suffolk, which is a charity that does loads of things around health and patient satisfaction, but one of the things that they do is they also let you publish independent your own review, your feedback of specific individual institutions. Here we've selected, because we are based in Ipswich, our closest hospital, Ipswich Hospital. And what you can see on their website is, if you under review, you can of course leave your feedback, but you can scroll down a little bit on that same page and you can see reviews. Now we can see that 1,600 reviews approximately have been published here. So the task that we wanted to achieve with that these projects is we wanted to extract that information from here, from one of these reviews here, and we wanted to be able to essentially store the title, the department, the date, the rating, and the content of that review in separate fields. And in doing so, we then would be able to analyze the sentiment or the opinion, whether it was positive or negative, of that paragraph here. So what we then did is we created our little Python notebook. And what we did is we installed the two packages that actually I have got pandas available anyway, but you could be installing that if you don't have that already. But Beautiful Soup 4 was what we installed here, and requests for being able to retrieve JSON data files were needed. Then we launched some of these libraries here, so pandas as well and the time. And then all we need to do is we need to define certain elements of this. So what we wanted to extract here is we wanted to extract a row, let's say, of data for the customer review. And the customer review would have components, as we said, and the components would be the head of that review. I will show you what that maps into. We wanted to extract the department that this was based on. I will progress a little bit quickly and then I'll come back to these in just a second. We wanted the comment date, the date that this review was published. And we wanted to also, sorry, there's loads of comments on different ways of doing that. I'm skimming through the ratings and of course the actual comment body. So these are all definitions. We define them in various ways. So let me take us back to the top on how we have defined the actual head of that comment. So you'll notice that this code here points to a specific HTML element. This is the H3, heading 3, essentially. And what you can see is that if you actually go back to the reviews page and you open the inspect element of that page, so let me try and do that quickly. And hopefully you can see that. Now, if you highlight the heading of that comment, very good service in the eye clinic, you'll see that that is actually, there it is, it's now highlighting that for me. It's actually an H3 element. So what I've done in my little crawler, I've said, is wherever you see a heading 3, store that the content of that heading 3 is essentially what's inside the 2 tags, store that as my head for that comment. And you'll see later on, I can see that the actual inspect element doesn't show up. So what I'm going to do is I'm going to try and see if I can actually hover over it so that you guys can see that clearly. Let's go back to the very good service is actually a heading 3. So let me see if that makes any difference for you. No, it doesn't. But hopefully by hovering over, you see something special. Let me see if I can show this. Sorry about that. Right, so this is my heading 3, very good service in the eye clinic. If I hover over the eye clinic here, we'll see that's an H5. So remember, this is the department. If I hover over November 26, this is a special one, a div with a service review date. And if I hover over the ratings, this is the service review rating, star rating, compact. So all of these tag names I will then use to include into my Python notebook here. So you see, I ask my little crawler to find H3, and the contents of it should be stored inside the comment head. It should find my H5 tag, and whatever goes in it should be stored as department. And for my review date, it should find the div element of this and store that as part of, find the class that's called service review date and store that as part of the comment date. And in a similar manner, find the, this is slightly more complex, I'll explain in a minute, find the service review body div and store that as comment body. So that gives you a feel for the elements within it. And essentially what happens, if I try and zoom out a little bit so that we can see the full scale of this, what we can then do is we can ask it to display this data frame in a kind of a tabular format. So as soon as this is imported, let's say, all of these reviews will be stored inside a CSV file that I will call here customer reviews CSV. The data frame will have the following columns. From the customer review, comment header will be essentially the title, department, comment date, ratings, and comment body. And what this will essentially do, as soon as I print that, you'll see that essentially it has stored the a couple of dummy points as well, but you can see that it's starting to store the comment body, so the review body, as well as the ratings and the date of that specific comment. Hopefully that's given you an overview of this. I will make sure I publish that notebook alongside the slides so that you can actually have a look at what I've got. I could not show you, unfortunately, the elements around that. So thank you for bearing with me around that. Hopefully you should be able to observe that through the actual Python notebook once we get that. So I would like to round us up and conclude this quick seminar with the ethical considerations around web crawling. So there's been loads of discussions around whether web crawlers are allowed to crawl whatever that is out there. So and whatever and whether what is out there and is publicly available as a website, if it can be stored as data. As scientists, we have the means of ensuring that we ask people for permission before we crawl their websites. We want to make sure that we don't run that crawling activity of each one of these reviews continuously. So you might you will see when you explore that notebook that we suggest that essentially every time a review is stored, there is a gap in between, in terms of a time gap in between each one of the requests to get data from that website, so that we don't overload them with requests and crashing them. But more importantly, we should be respecting the rules that the websites have on which pages can be crawled and indexed and which can't not. In the old days, it used to be done by a little file that was stored on a server of that website called robots.txt that defined what is a LAN and what isn't. But more importantly, need to be transparent about what is the practices and essentially what it is that we would be doing when we crawl a website. Other elements around that would be which brings up an interesting discussion about some of the ways that some of these models have been trained, is to essentially make sure that you are transparent, as we said, as to what we're doing, why you're doing it, and how you're storing that data, if you're storing it at all. Hopefully that was a very quick run through of what a web crawler is and how it operates. I hope that has given you some ideas about ways that you could be using it for your own work. It is a very interesting means and a very usual means of collecting data, but there are some issues that need to be taken care of in terms of how often you do that, making sure that you don't mess with people's websites essentially, but also in terms of your own practice as well as a data analyst and as a scientist. I'll leave that on for any questions, but I hope that was useful. I hope you have a good lunchtime and a good rest of weekend. Right, oh, I have a question from somebody, so let me try and see if we can see that. So there is a question whether this tool can be applied for sentiment analysis, whether essentially the same pipeline, I guess you mean, could be implemented for developing a price prediction algorithm. Yes, definitely. You could be extracting the data that you would be feeding on your price prediction algorithm for sure. But what is important is to pay attention to how you're using it, if you're okay, and if the website that offers the data, they are okay for you to use it in that way. But there's nothing wrong, except if there are any like the website doesn't want you to get the data out in that way, there is no reason why you couldn't be doing that. So yeah, if you can extract the data in that way and the data comes in a kind of structured format like that, there's no reason why you couldn't be setting up a web crawler to get that data from space into your own set of data. Hopefully that was useful, Prem. If there are any more questions, please let me know. Right, I'll round us up here. Thank you again. If there are any more questions, I will be answering offline as well. So thank you very much for coming today. Looking forward to seeing you next week when we have Paul Graham talking about tools for AI around offered by Oracle. So there is a really interesting set of cloud services that are being offered specific for data science and AI that from Oracle. So he'll be doing an introduction and a quick demo. So hopefully we can see some of you there.